The first derivative test. Like I said before, Chapter 2 is the most difficult because you're actually learning the calculus. Chapter 3, I like to say we're applying the calculus. Okay? So this first derivative test. First of all, what do we have to remember about derivatives? What does it have the capability to measure? Slope, right? So I just want you guys to remember. Okay? F prime of x is equal to the slope of a function at a given value of x, right? That is not a surprise to us. You guys have been creating tangent lines using this information, okay? So here's what we're able to do with this information, okay? So here's what the first derivative test says. So first derivative test, okay? It will indicate if the function is increasing or decreasing, okay? So it's going to indicate if the function is increasing or decreasing. Now, how it's going to do this is, well, when does a function increase? What does that look like? If you have a positive slope. So if we take a derivative and we plug it in and we see that if f prime of x is positive, that means the function is increasing at that point. The original function. Okay. Similarly, what happens if your derivative is negative? The function is decreasing. Now, something that we've talked about a lot, but we've kind of, yes.
If it's 0, then is that what you're saying?
I was, yeah. So I'm skipping right over it. Like, I'm saying if it's positive, it's increasing. If it's negative, it's decreasing. But if it's 0, what do we know at that exact point?
Undefined?
Not that it's undefined. It means the tangent is a horizontal line. It's not neither increasing or decreasing at that point. It means it's a minimum or a maximum, right? That's what that means, okay? So, let's just look at our first example, just to kind of get us...
So if fx equals 0, then it has a minimum.
Not f of x. Be careful how you say that. If f prime of x equals 0, it has the possibility to be a minimum or a maximum, okay? Example 1. Let's just take it easy. So f of x is equal to 4x plus 3. You guys are all really familiar with this. What kind of function is this? Linear. We all know it's linear. If we take a derivative, what does that look like? Just looks like 4. And therefore, what do we know about this function? The slope is always going to be 4 and positive, so this function is always increasing. So in this case, this function is always increasing because slope is positive.
Is that how we have to, if there's a question, that's how we would have to answer?
We'll get into that. This is a little bit different because this is for all x's. Eventually, we're going to get to a point where it's going to change if it's increasing or decreasing depending on the x value. Okay? So, example 2. Let's just do this. So, f of x equals negative 2x plus 1. Again, if I take a derivative, what do we notice? F prime of x is going to be negative 2. Therefore, this function is always decreasing.
since you got some mucus.
Yeah, I had a cold all day.
That's
Oh, God.
It's the best time to get sick. Okay.
No, son, you can't stay home from school, dog. You're off school.
Okay. So, you guys good?
I'm only here like 3 days a week anyway.
Okay. So guys, the next question is, like, what happens if this derivative isn't a constant? So, like, because both of these are linear, the derivative was just a constant, which means it was just a single number, right? So let's look at an example where maybe it does something different, okay? So let's look at a quadratic, okay? So example 3. Let's say g of x equals x squared minus 6x plus 8. Now, before we even take a derivative, when we start to analyze this, okay, what do you know about this function? What do you know about it? It's quadratic, which means
Parabola.
it's a parabola.
Minimum or maximum?
It's either going to have a minimum or a maximum. And looking at this, I can actually determine what it is. This, the slope is not going to be constant, right?
They're at 3 negative 1.
So in this situation, I'm going to have a minimum because this parabola is opening upwards. Has a y-intercept of 8, right? Like, we could get fancy, but we're good. So we just kind of know the general shape of this, right? But what we understand is because it has a minimum, at first this function is going to what? It's going to decrease, and then it's going to get to its minimum, and then it's going to start increasing again. Okay? So let's take a derivative. Let's see what that means. So g prime of x. The derivative of this is going to be 2x minus 6. Okay? Now, what point is really going to help me out understand this parabola? No. I don't want an ordered pair. I want the name of this in this case. The minimum. The minimum is really going to help me understand this parabola because that's the point where it's going to change from what? Decreasing to increasing. If I understand a parabola, it kind of looks like this. Here's the minimum. What kind of slope is at this point? 0, right? So if n equals 0, why is this so nice to have right here? Exactly, because I can let my derivative equal 0 and solve for x. Okay. Now, what am I going to be finding here? X is equal to 3, yeah. I don't care about that yet. Okay. So guys, this is how I choose to understand, like this is a quadratic. We understand it's going to have this shape, but this is how I choose to map it out. I use a chart, okay? So what I do in this chart is I say I have x values, and then I kind of do this. I pick out x values. So the most important x value I want to look at is 3 right now. So I'm going to put a 3 right here. Okay? So, what I'm going to put, this is x, I'm going to put f prime of x right here. Okay? Now, if I plugged in 3 into f prime of x, what did I get? What was my slope there? It was 0. That's why it was so important. Okay? Now, we already know because we know some stuff about parabolas, but let's choose a value that's less than 3. What value is less than 3 that's super nice? 2, 1. 0 is my favorite value to plug in. Why? Because anything multiplied by 0 is 0. Okay? 0 is my favorite number to plug in. So here's how this chart is going to help me. What happens if I take 0 and I plug it into f prime of x? I'm sorry, g prime of x. I'm going to get a negative 6, right? So I don't even need the number. The only thing I'm caring about is the sign. So when I take 0 and I plug it into g prime of x, I get a negative value. Okay? You can put negative 6 to help you understand, yeah, you got a negative 6 at that point. And then, what would happen if I plugged in a value greater than 3? So let's choose one.
4.
4. If I take 4, plug it into g prime of x, so 2 times 4 is 8 minus 6 is 2. What do you notice about that value? It is positive, which is exactly what I was predicting, because what's happening here? Well, in g of x, the function is doing what? It's decreasing. Over here, it's increasing. And what is this going to be called? What is this point going to be called? It is a minimum. And I'm going to say it's a relative minimum. Okay? So, this is what the function is doing. Okay?
So how would we write that out? Like, do we just leave it as b?
So,
After.
So here's how this is going to apply. Your homework is going to ask you, when is the function increasing or decreasing? So what I'm going to say is, the function is decreasing. Well, now I'm just going to look at my chart. When is it decreasing?
Negative 3.
From negative infinity, because that's left of 3, up until 3. Can I include 3 or no? No. So notice it's an open parenthesis. Okay? And what else do you know? It's decreasing on this interval, and what? And exactly. It's increasing, open interval, 3 to positive infinity. And one other item that was super important in this chart, we know it's decreasing and increasing, and it has a what? Has a relative min at, we're not talking about that right now, 3, comma, has a relative min at 3, comma, what am I looking for? The y value in what, my derivative or my function? The original function, because that's where minimums occur, right? So, if I plug 3 into this original function, I get 9 minus 18 plus 8, I would get negative 1. Okay? You guys with me?
I'm with you.
Okay. So let's try 2 more examples for today. Okay. Whoa, maybe not. Okay. So, example 4. So f of x is equal to x cubed minus 3 halves x squared. Okay? So realize I kind of changed it up a little bit into a cubic function, right? So, what are we going to do first? We're going to take a derivative. So let's see, f prime of x, we're going to use the power rule. X cubed, you can take a derivative, is just going to be 3x squared. When I take a derivative of negative 3 halves x squared, I'm just going to get negative 3x. Because 3 halves times 2 will just be 3. And then the x will become to the first power. Okay? Now, guys, where do we go from here? So we could factor, but before we even factor, like, what are the values that I'm looking for here? When the slope is what? 0. Why am I looking for those? Because that indicates what? A minimum or a maximum. So before we even start to factor, which I love that you guys are starting to do, we're going to set this equal to 0 because I need to look for minimums or maximums, which means it has a horizontal tangent. Okay? So now, yeah, you guys look at this and please tell me you know what they have in common. 3x, yeah. So 0 equals 3x times x minus 1. And then going back to our algebra skills, what am I allowed to do with both of those factors? Exactly. And 0 is such a nice number. And as I go through this, you're going to get that x is equal to 0 and x is also equal to 1. Now guys, just remember, when you do these, These are possible minimums and maximums. It doesn't mean they're gonna be minimums or maximums. We have to go and do that chart to test to see if the signs are switching. If they switch, it's a min or a max. If they don't, it's something else. Okay? All right. So I'm just going to go ahead and do my chart. What are my really two important x values that I want to make sure I talk about? 0 and 1. So I'm going to put 0. I'm going to leave some space, and then I'm going to put 1. You'll see why I do that in a second. So there's x. And then we're going to talk about f prime of x. Now, the reason I want to leave space is because I want to test both the left and right of these points. And if I put them right next to each other, I don't leave myself any room to put in a value. Okay? So, let's go back. Why were 0 and 1 really important in the derivative? Because it had a slope of 0. Yep. And they're possible in the function minimums or maximums, right? Okay. So now, let's go left of 0. What number's left of 0? Yeah, -1. And guys, what I want you to understand is you could plug in any number left of 0. Okay? So go ahead and plug that into your derivative. When you plug it in, what are you going to get? No, we're going to get 6. We're going to get a positive 6. But guys, remember, it's not important about what number you get. It's important about the sign. This is a positive. So this is a positive value. Now, we have to go to the right of 0, but I also want it to be smaller than 1 because these were important. So what's a number that's in between 0 and 1? 0.5. 1/2. Okay, you plug in 0.5 into a quadratic the way that it is and multiply it. Tell me how that goes. I like using fractions because I know how to square a fraction easier than I know how to square a decimal. Okay? So if I plug in 1/2, you're going to get 3/4 right here minus 3/2. Again, don't worry about the number. Is 3/4 minus 3/2, is that going to be positive or negative? It's going to be negative. So that's all you have to worry about. You don't have to worry about the exact value. You just need to worry about the sign. And then what's a number that's greater than 1? 2. So let's go ahead and plug in 2. I'm going to get 2 squared is 4 times 3 is 12 minus 2 times 3, which is 6. So again, I'm going to get a positive. Now let's talk about what's happening here. This is what's happening in my derivative. In the function, what does a positive mean? It is increasing. What does a negative mean? Decreasing, which means at this point, at this x equals 0 point, what is it? What happens if I change from increasing to decreasing? So let's look. I'm changing from a increasing to a decreasing, which means this is a max. Okay? And then over here, I'm decreasing here. Since it's positive, that means it's increasing. I'm just going to kind of draw a little sketch. What does that mean right here? It's a minimum. And now we know a whole lot more about this function without actually graphing it. Okay? So if I want to talk about where is this function decreasing? So let's look here. So I see that it says decreasing, but what two numbers is it in between?
0 and 1.
So that's my interval. From 0 to 1, it's decreasing. Okay? Again, if you're wondering how I did that, decreasing is between 0 and 1, so that's my interval. Those are my numbers that I'm using. I'm allowed to use them because they're my max and my min. Okay? Increasing, well, it's increasing here, but see how I don't have anything to the left? There's no point to stop it. That means it's negative infinity. Where is it stopping? At 0. Okay? But I also have another situation because it's also increasing, so we have to do union. Where does it start increasing? At what number? 1. And I see how I have no value over here, so it's up to positive infinity. Okay? we have a relative max at what? The x value is 0, but I have to go back to the original function up here. It's also going to be 0. You have a relative min at 1, comma, I plug in 1, I'm going to get 1 cubed is 1 minus 3 halves times 1, so I'm going to get negative 1 half. And I know all of this information about this function without ever graphing it by using calculus. Okay?
I feel like you're gonna make this graph.
I will. It's called curve sketching.
Tomorrow, actually.
In a couple of days. No, that's a lie, like a week.
Thank God.
We have to do the second derivative
It's a
test.
very long process.
No, it's not. You stop? Would you stop trying to intimidate them?
You just have to put it on a graph, though. It's not that long.
Okay,
The way I did it, I should have been
example 5.
Everything's hard, and you're gonna hate that.
X squared minus 4 to the 2/3.
Oh,
Okay?
no.
No, I needed to put a function on here that you guys aren't comfortable with, like taking derivatives.
Will we ever get comfortable with these?
Yes. Come April, you guys are going to wonder why you struggled with this so much.
Come your senior year of college.
You guys are still gonna be taking anything else.
Okay, no. Alright guys, so before we even take a derivative, what rule is this? Chain rule. So that's the first step that we even have to know what this is. So chain rule says to, well, how do you guys prefer it? So you want to drop the power. So it's 2/3 times x squared minus 4 to the negative 1/3, and don't forget to take the derivative of the inside. So times 2x. That's the derivative right there. Okay? Now, I might do a little finagling to help me understand this a little bit better. So I'm going to make it look a little bit prettier. Okay? So g prime of x in this case, if I take 2 and multiply it times 2x, what is that going to be? 4x. Now, that 3 is in the denominator, and this negative 1/3 will also mean it goes into the denominator. So notice I'm just making it 1